Please, this is group three. Please, this is group three, and we will be presenting on students' performance checking using machine learning algorithms. These are my group members. You have Benjamin, Brown, Akwesi Entry, Samuel Kinupua Odia, Kennedy Omane, and Emmanuel Kwame Edu. First of all, I would like us to go through the code and then come back to the documentation. Okay. So please, this is the code for our work. We used three different algorithms. We use the random forest algorithm. Okay. Yes, we use the random forest algorithm. We use the linear search, sorry, the linear algorithm. Yeah. We also use the support vector regressor and then the decision tree. Okay, so this is a little bit about the code. First, we imported the necessary libraries. We brought in the data and then we tried to check the sample of the data. So the data has lots of features, but we had already pre-processed the data and then extracted only three features out of the lots of features we had initially. Initially, we had about, I think, 33 features, but we extracted only three. That is why you see only four features here. Yeah. We go ahead and then divide our data set into the train and then a test data set. We divide our data set in such a way that 30% is used for training. And then we use 30% not only for random forest, but also for support vector machine, which is also 0.30, which is 30%. The decision tree is also same, 0.30, that's 30%. And then the linear regression, also the same. This is just to make sure that we have equal parameters in doing everything for the test. Okay, so I can proceed. We go ahead to split our data and then build the model. So this is the random forest regressor, the random forest, and this is an instance of the random forest regressor. And then we go ahead to input the test so that it does the prediction, and then we do the calculation. So this is to calculate for the R score, which we had 90.31%. Yeah. We go ahead and then fits in X and Y. Now, after training everything, we just build the entire model. So this is the final forest regression model. We try to dump it, and then we tested it again. So after testing, we inputted the features, which is 15, 2, and 16. Now these features 15, 2, and 16 represents the age, the number of times the person was absent, and then the score the person had in the initial score. So the 15, 2, and 16 simply means the person is 15 years old, was absent twice, and then his initial score for the test was 16. And then let's see what the model predicted. It's predicted 17. Yes. So this is what we have for random forest model. The same goes on to support vector regressor, and then the same goes on for decision tree. Okay, now we will walk through the documentation and see what we have done so far. Okay, so please, this is our documentation. Now with the documentation, just like I stated earlier, the name of the group members, here we are. We did some abstracts, we did some introduction, and then some literature review. We worked on some studies that people have already done. Yes, that is, numerous studies have been conducted to predict students' performance utilization. So we did some extensive work on the student performance research, as in those who have already worked on the same projects. And we had quite a lot of people. Then we also have our main objectives. So the main objective of our project is to apply machine learning techniques to predict students' academic performance. They use the predictive models to forecast final academic outcomes based on the historical academic records and behavioral indicators. Data methodology, and then the stages. So the first stage was data pre-processing, just like I initially stated. We pre-processed the data. Initially, the data had about 33 features, but we extracted lots from it. And then, we extracted about 30 features off because they were not useful, they were not necessary. And then we used only 3 features out of the 33 for the prediction. Okay, so this is our um, methodology flow. Yes, this is our methodology flow. Yeah. Okay, we can go ahead. Sorry. Just trying to zoom in so we see the methodology flow. Okay. So initially we did data. Good. Initially we did data pre-processing. That is when we got our data, we took lots of data out and used only 3. We did cleaning, which is also same as the data pre-processing, and the data reduction. That is, we reduced 30 features to only 3. After that, we built these 4 different models: the support vector, machine regressor, random forest, decision tree, and then the linear regressor. Then these were the performance evaluation. We calculated for the F test, which is the overall test of each model, the RMSE, that's the root mean square error for each of the models. Okay, I think the colleague has raised his hand. Okay, I continue. We also did MSE as the mean error, and then also the MAE, and then the R square score, all to check for the performance of the models. Okay. Now, after the performance, we realized that decision tree had the highest performance, scoring 90.64%. And then the worst performance was the linear regression or the linear regressor. All right. Now, these are the formulas for each of the models. For linear regression, we have mathematical equation to be this. Yeah. And then for the performance of the linear regression, we have a detailed table which highlights the performance. We move on to random forest regressor. Then this, as we can all see, is the formula for the random forest regressor. And then we also talk about the performance of the random forest regressor in terms of the feature importance. Okay. We also talked about the performance metrics of the same random forest regressor, which has been highlighted here. Then we wrote a little bit about support vector machine. Now this is also its table. Sorry, this is the formula for calculating for the support vector machine, or its formula, yeah. And then we did some performance metrics here to check for the performance of the model, which has been detailed here. Then we also worked on the decision tree. This states the formula, and then this states the performance metrics of the decision tree. Okay, and then we also highlighted the performances in terms of bar charts. So with respect to the R square score, decision tree was the highest. That is, it performed best with the errors, the mean absolute error. The one with the most errors was the linear regression model, had the highest mean absolute error. And then the root mean square error, the highest was the linear regression model again, which performed very poor. We wrote our conclusion, and then we had a live performance. This is an interface of our model where people can go ahead and then test our model. So this is the live test. We select a model, we input the student's age, and we see the student is 16. The number of times the student was absent, let's see 3 times. The initial score of the students, let's see 14. Let me move this one somewhere. After clicking on predict performance, it does the prediction, and then we notice that the person had 13/20, which means 67%. Thank you. This is the end of our presentation, Group 3.